Ever pondered how a rocket maintains its trajectory or how the economy fluctuates? The answer lies in the realm of calculus, and more specifically, in functions. But what exactly is a function? In the next 7 minutes, we'll delve into this fascinating concept and unravel its mysteries. So let's start at the beginning. Picture a machine. You feed something into this machine, and it produces a result. A function, in the realm of calculus, operates similarly. It takes an input, processes it, and then produces an output. This output is entirely dependent on what you feed into the machine, or in our case, the function. A function is a rule or a set of rules that assigns each input exactly one output. This is a crucial point to remember. Imagine a vending machine. For every coin or note you insert, you get a specific snack or drink. The same principle applies to functions. But how does one express a function? In mathematics, we usually represent a function as fx, where f denotes the function and x is the input. The output, or the result of the function, is often represented as y. So, when we say y equals f of x, we mean the output y is determined by the function of the input x. Now, functions come in all shapes and sizes, each with their unique characteristics and graphs. Some are simple straight lines, while others are complex curves. But they all share one thing in common. They map the relationship between two sets of quantities. In calculus, functions are indispensable. They form the backbone of both differential and integral calculus. In differential calculus, we deal with the rate of change of quantities, which is essentially understanding how one quantity changes with respect to another. Here, functions help us determine the slope of a curve at any given point. In integral calculus, on the other hand, we deal with the accumulation of quantities. Functions help us determine the area under a curve, which can represent the total accumulation of a quantity over a certain period. To summarize, a function in calculus is a rule that assigns each input exactly one output. It's represented as fx, where f is the function and x is the input. Functions are fundamental to both differential and integral calculus, where they help understand the rate of change and accumulation of quantities, respectively. Remember, functions are everywhere, from the trajectory of a rocket to the fluctuations in an economy, and understanding them is a significant step towards mastering calculus. So next time you see a curve, a graph, or a machine, think about the functions at play. And remember, every function has a purpose, just like every input has an output.